Hello everyone, today I'm going to talk about bounding consumer preference. As an application, we consider a problem of predicting consumer preference. We consider different baskets of goods consisting of different amounts of consumer goods. And a goods basket is specified by a vector x from 0 to 1, where xi denotes the amount of consumer goods I. We assume that the amounts are normalized so that x equal to 0 is the minimum, and xi equals to 1 is the maximum. Given two baskets of goods x1 and x2, a consumer can either prefer x1 to x2 and also can prefer x2 to x1, or consider x1 and x2 equally attractive. We consider one model consumer whose choices are repeatable. We model consumer preference in the following way. We assume there is an underlying utility function, U, with domain 0 to 1. Ux gives a measure of the utility derived by the consumer from the goods basket X. And given a choice between two baskets of goods, the consumer chooses one that has larger utility, and it will be ambivalent when the two baskets have two equal utility. It is reasonable to assume that U is monotone and non-decreasing. This means that the consumer always prefers to have more of any good. With the amounts of all other goods the same, it is also reasonable to assume that U is concave. And this model's satiation or decreasing marginal utility as we increase the amount of goods. Now suppose we are given some consumer preference data, but we do not know the underlying utility function U. Specifically, we have a set of goods baskets A1, A2, and AM, which belong to 0 to 1. And some information about preferences among them. UA1 is greater than UAJ for IJ belong to P, and UI greater and equal to AJ for IJ belong to P weak, where P and P weak belong to a matrix like this are given. And here P gives a set of known preference. I and J belong to P means that basket AI is known to be preferred to basket AJ. The set P weak gives a set of non-weak preference. I and J belongs to weak means that basket AI is preferred to basket AJ, or that the two baskets are equally attractive. We first consider the following question: how can we determine if the given data are consistent? For example, whether or not there exists a concave non-decreasing utility function U for which this is like. And this is equivalent to solving the feasibility problem. Find U. And it's subject to U is concave and non-decreasing. And UAI greater than UAJ. IJ belong to P P, UAI greater than or equal to UAJ I and J belong to P weak. With the function U as the optimization variable, since the constraints in this formula, we can express the problem in the equivalent for the constraints are all homogeneous. So the new find U and it's subject to U to it's concave and non-decreasing. UAI greater than AJ plus 1, I and J belong to P. UAI greater than AJ and IJ belongs to P weak, which uses only non-strict inequalities. This problem in turn can be cast as a linear programming feasibility problem using the interpolation result on what we calculate before. So it can be like that. Find what U1, U2 to UM and G1, G2 to GM. They are subject to GI greater than 0, I equal to 1, 2 to M. UJ is smaller than UI plus JI, AJ minus AI. RI and J is from 1 to M. UI greater than UJ plus 1, I and J belongs to P, and UI greater than UJ, I, J belongs to P weak. By solving this linear programming feasibility problem, we can determine whether there exists a concave, non-decreasing utility function that is consistent with the given sets of strict and non-strict preference. If this formula is feasible, there is at least one such utility function, and if it's not feasible, we can conclude that there is no concave increasing utility function that is consistent with the given sets of strict and non-strict preference. As an example, suppose that P and P weak are consumer preference sets are known to be consistent with at least one concave increasing utility function. Consider a pair K and L that is not in P and P weak. For example, consumer preference between baskets K and L is unknown. In some cases, we can conclude that the preference holds between basket K and L, even without knowing the underlying preference function. To do this, we augment the known preference like the first subject. And with the equality UAK is smaller than UAL, which means that basket L is preferred to basket K. or they are equally attractive. We then solve the feasibility linear program like this, including the extra weak preference UAK is smaller than UL. If the augmented set of preferences is infeasible, it means that any concave, non-decreasing utility function that is consistent with the original given consumer preference data must also satisfy UAK is greater than UAL. In other words, we can conclude that basket K is preferred to basket L without knowing the underlying utility function. That's all. Thank you.